Okay, so this week we've revised sequences and told you to do one lesson of preview work of year 13. So the topic we're going to look at is something called Newton-Raphson. And Newton-Raphson is a powerful technique that lets us solve equations such as f of x equals 0. So for this to work, the function needs to equal 0, so we can always rearrange to do that. And then there's a nice formula which you'll get given in your formula booklet, which is an iterative sequence. Xn plus 1 equals xn minus f of xn divided by f dash of xn. And you pick a starting point, you sub it into there, and you get next answer, which is closer to the answer to your equation. Then you sub that answer back in, and you get the next approximation, and you keep doing that until you get to a root. So let's do an example. That's probably the best way of doing it. So if we have the equation x cubed plus 2x squared minus 5x minus 4 equals 0, and we want to try and solve that. Well, we can't solve cubics easily algebraically, so we have to use a numerical method. So that means Newton-Raphson. So first of all, we need to decide what our function is. So f of x is this thing here, x cubed plus 2x squared minus 5x minus 4, because it's already equal to 0. Then we need the derivative, so f dash is 3x squared plus 4x minus 5. And then we can use that formula to get a sequence. So the formula for my sequence is this. So it's the function at the top. So it's xn cubed plus 2xn squared, take away 5xn, take away 4, all over 3xn squared plus 4xn, take away 5. Okay, so we have a sequence. Now we need a starting point. So you remember from GCSE trial and improvement, where you would sub numbers in and you try and get a number that's too big and too small. So I've already done this, but if we sub in f of 1.8 and f of 1.9 into f, so let's look at doing that. So 1.8 cubed plus 2 times 1.8 squared minus 5 times 1.8 minus 4. Why did that? Minus 5 times 1.8 minus 4. So that gives us minus 0.688. And then if I change all the 8s to 9s, we get 0.579. So this one's below 0, this one's above 0. So from GCSE, that means there must be an answer in the middle of 1.8 and 1.9 that equals 0. So just to keep the numbers nice, I'm going to start off with my first approximation, and we normally call it x0 when we use Newton-Raphson. x0 is 2. So to get x1, we would use this formula. So x1 would equal 2 minus 2 cubed plus 2 times 2 squared, take away 5 times 2, take away 4, over 3 times 2 squared plus 4 times 2, take away 5. Yeah, but instead, remember you can use that answer button on your calculator. So 2 equals, and it's answer minus answer cubed plus 2 times answer squared. And that's what we take away 5 times answer, take away 4, over 3 times answer squared plus 4 times answer, take away 5. So my next one would be, let's just put that there for a second so you can see it. X1 would be 1.8666 I press equals again, the next one, so x2 would be 1.855, etc. Press it again, x3 would be 1.8557, etc. Then x4 would be 1.85577, etc. So you can see that it looks like the answer all begins with 1.855, then 7. So 3 decimal places, my answer would be 1.856. Now I'm going to check that using solving. So it's hit x cubed plus 2x squared, take away 5x, take away 4. There we go, 1.85577, etc. Yes, this method does work. Okay, let's do, actually, before I do another one, I'm just going to show you as well, or remind you how we can use the sequence mode. So go on to recursion, remember? Then I'm going to delete that. If you haven't already changed the type to the one that's got the an plus 1, so f2, and then we're going to type in the formula. So it was xn, or they've used a, so an, take away a fraction, an cubed plus 2 times an squared, take away 5, an, take away 4, over 3, an squared, plus 4, an, take away 5. Now we change the setting. So we're starting, so press A0 because we're using x0 to begin with. So we're starting from 0, and let's do the first 10. So A0 was, we tried 2, didn't we? So if I draw the table, there it was, my first one was 2, and I got 1.8666, and then I've got all those numbers. Like, if I keep going down, they're all pretty much the same. Yeah, now you could try that with different settings. So if I start on, let's start with 1. See what happens if I start on 1. Gets me back to that number. Let's start on 0. What happens to 0? This time it goes to one of the other roots. Remember, a cubic could have up to 3 roots. Yes, there's different start numbers, different x0s can lead to different roots. Okay, let's do another one. Let's do the equation. Let me just find one I want to do. X squared sine x equals 2x minus 1. So the first thing we need to do is we need to get that equal to 0. So x squared sine x, take away 2x plus 1 equals 0. So this bit's going to be my function. So my derivative, well, for this first bit, x squared sine x, I'm going to have to use the product rule. So u is x squared, v is sine x, so u dash is 2x, v dash is cos x, times them. So I get x squared cos x plus 2x sine x minus 2x differentiates to minus 2, and the plus 1 disappears. So my Newton-Raphson formula, the sequence is xn plus 1 is xn minus f of xn, so xn squared sine xn, take away 2xn plus 1 all over dashed of xn, so xn squared cos x n plus 2xn sine xn, take away 2. Okay, we need a starting point for this. So we're going to do x0 is 2.4. So to get x1, so I'm just going to show you just for the first one, to get x1, I would sub in x0 into there, so 2.4, take away 2.4 squared, sine 2.4, take away 2 times 2.4 plus 1, all over 2.4 squared, cos 2.4, plus 2 times 2.4, sine 2.4, take away 2. Yeah, you need to make sure you're in radians for this, because whenever we differentiate or integrate, we need to be in radians. So I'm in radians, so it's fine. Do it all. So again, I'm going to use the answer button trick. So 2.4 equals, then it's answer, take away. Instead of xn, I'm typing in answer. I should put it here so you can see. The fraction answer squared times sine. Then I'm going to put brackets around the answer just to make sure. Take away 2 times answer plus 1 over answer squared times cos answer, again I'm going to use brackets, plus 2 answer times sine brackets answer take away 2. So my first approximation, according to this, is 2.43, 0.17, etc. Press enter again. My next one would be 2.42883, etc. Then x3 would be 2.428827. And look, as I keep pressing enter, it doesn't change anymore. So that looks like my answer. So let's solve in it. So it's x squared times sine xy, I don't need a bracket there, sine bracket on that x equals 2x take away 1. I don't have any limits to type in, so it's going to take a bit longer to work them out. And we want the one up into 2 point something. They got 2.4288. So this method does work. And again, just to go on the recursion. So it would be an take away. No, I'm just going to leave the fraction, just going to delete everything on it. So it's probably quicker to delete the whole thing. So remember, n is just xn, so it's n squared times sine n. Let's try it out the brackets. Take away 2n plus 1, and it's n squared cos n plus 2 n sine n minus 2, and we're starting. We'll do from 0 to 10 again. The starting number was 2.4. So there we go. There's all different approximations, look, and they get pretty accurate very fast. So Newton-Raphson's a really quick one. Okay, so the exercises you want to try, work out what the function is. Remember, it needs to equal 0. Differentiate it, then work out your iterative formula, and either use the recursion method on your calculator or use the answer button trick. And then there'll be parts of the questions that says show that an answer lies in an interval. So that's when you sub both numbers in and one's positive, one's negative. And sometimes you might get asked to prove that your answer is accurate to so many significant figures. So to 3 significant figures, this would be 2.43. So I'm going to rub this to that out, just get back here. So part of the question might say, prove that x equals 2.43 is the answer to 3 significant figures. So what you have to do is you have to think back to GCSE and think, what's the lowest number that would round to 2.43? What's the biggest number? So hopefully you'll remember that's upper and lower bounds. So 2.425 and 2.435. Then when you sub these numbers into here, one will be negative, one will be positive. So therefore the answer must round to 2.43. It's in the middle of these two, which must be 2.43 to 3 significant figures. So have a go at the practice. If you need to miss those bits out, miss them out. But I want you to practice the Newton-Raphson in particular, using the sequences. So it's combining your sequences skills and your differentiation skills. Any issues, drop me a message.